Hello and welcome to another episode of the CG Garage. This is episode number 437, featuring our good friend and my coworker, Simeon Balabanov, who is the Senior Product Manager for Chaos, Vantage, and V-Ray for Unreal. And I've actually wanted to talk to him a little bit because there is some really great stuff that he's been doing recently. Vantage 2 has come out, and we don't, as you know, on this podcast, we actually don't do very many episodes or hardly any episodes about our products because that's not necessarily what this podcast is about. But this is a product that I cannot tell you how excited I am. I have been obsessed with real-time ray tracing for a long time. And what I mean by real-time ray tracing, I mean full ray tracing, no little compromises here or there, just full out ray tracing. And Vantage 2 coming out is a huge step for us. Though some of you guys may not even know what Vantage is and what it is as a product, and I am very, very excited about it. So Simeon and I sit down and talk obviously about what Vantage 2 is and what Vantage is in general and how are all the new things happening, but also get into a discussion about the implications of real-time ray tracing and how that's going to affect all of the industries and everything that's going on in terms of the world of rendering, and why ray tracing is such an important thing to distinguish itself from traditional real-time rendering, which is done with rasterization. So big discussion, and we really get into it. And if you're interested in ray tracing, this is a good one to get into. So buckle up. Okay, so besides Vantage 2 as a product announcements, we do have a couple of other products that have come up with some updates. We have Phoenix 5 for Update 2, which has come out. Very exciting about that. V-Ray 6 for Houdini Update 1 is also there. So make sure and go check those out. Just go to chaos.com for that. We also have a special offer right now going on for cloud credits that is going through August 16th. And just go to chaos.com to check out our special offer, and you can get some discounts on some cloud credits. And that again is through August 16th. So just go to chaos.com for all the details on those new products, as well as that special offer for Chaos Cloud. A couple of events going on. SIGGRAPH, of course, is happening right around the corner. It'll be August 6th through the 10th here in Los Angeles. It is SIGGRAPH's 50th anniversary, which I am very excited about. Congratulations to SIGGRAPH and to all of those involved. And I will be excited to be there. So if you guys are at SIGGRAPH, let us know. Can check in with us. We'd love to see you. An extension of SIGGRAPH is going to be actually in London. We are going to be going to the Rainbow conference, and I'm actually going to be giving a talk there, which I'm very excited about. So that is going to be in London, August 29th through the 31st, and I'm going to be giving a keynote on the 31st itself. So very excited about that. Now, a little couple of announcements that will be happening from me at that time. So I'm excited about that, which you probably will start to derive some of that from the conversation I'm having with Simeon on today's episode. So very excited about that. So go check us out at the Rainbow Conference in London. We would love to see you guys there. Besides that, of course, if you want to know more about the podcast, you can always just go to our podcast page. That is chaos.com/CGGarage. And of course, we have a Facebook page as well. If you want to check us out there, facebook.com/CGGarage podcast. And if you'd like to watch these, our YouTube channel is one of the best places to do that. That is youtube.com/chaosgrouptv. Of course, suggestions are always welcome. We love your suggestions, and we've got some great ones recently. The best way to do that is to email us, labs@chaos.com. But for now, please enjoy episode number 437 with Simeon Balabanov.
Welcome to another CG Garage, where the Chaos Group talks. You'll know it's over when the last bucket drops. We're gonna fire off rays in high dynamic range. We know that ambient occlusion is passé. Global illumination won't lead you astray. And while image-based lighting is really swell, you need to make sure everything has Fresnel.
Very excited. So Vantage 2 just came out, right?
Yes.
And so you and I were talking about this, and first thing I think, not everyone knows exactly what Vantage is. So let's start with that. Let's go back a little bit, give a little history about Vantage, and where did it come from, and how did it sort of come about inside a company?
Right. Well, it all actually started as a tech demo or a technology tryout from the engineers at Chaos.
Yeah.
With the release of, or actually we got informed by NVIDIA that they were planning to release ray tracing hardware a bit earlier. We were given access to the tech.
So the first RTX cards.
Absolutely, the first RTX cards in conjunction with the DXR API from NVIDIA and Microsoft.
Right.
And that was actually introducing hardware ray tracing. And we got this a bit earlier to test it out to see if we can do something with it. Because of course at that time it was the first try. I mean, hardware ray tracing was tried a couple of times before, but this one showed really a lot of promises. So we dedicated some resources to R&D, and that resulted in Project Lavina at the time, a few years back. That was demonstrated, I believe it was SIGGRAPH 2018.
Yep.
Vlado Kolazov demonstrated that, and it was really, really exciting because it showed the power of hardware ray tracing.
Yeah, but at the time we did something a little different because people were doing hardware ray tracing, but they were doing it as a reflection on top of rasterized rendering, right? So we were doing something a little bit different.
Right, yes. Well, we've always been developer company that does ray tracing renders.
Right, pure ray tracing.
And that's absolutely everything is ray traced. Of course, there are multiple approaches you can do rendering with, and because NVIDIA announced DXR as a RTX and DXR as a real-time accelerated hardware ray tracing, or at least meant for real time. Many game engines also tried to implement this, or actually implemented it. However, as you know, game engines you utilize rasterization,
right?
And they just plugged ray tracing on top of that, by adding ray tracing in the shortcomings that the rasterizers typically have, like soft shadows or reflections or GI bounces, skylight illumination or IPO. And we didn't want to do that. We just wanted to see if we can speed up our regular fully ray traced engines, or at least come up with an engine that is fully ray traced, and see how much the performance is. If it can go real time, that would have been a great plus, and huge advantage. So obviously we because the first early tests showed a tremendous increase in computing power. We figured out that optimization of the engine could go a long way. And I think we've talked about this a lot of times, that rendering actually consists of, or at least ray trace rendering consists of two parts: throwing rays around, calculating the rays around, and then shading those rays to actually determine the color. When we have speed optimization or hardware acceleration for one of the parts, we still don't have acceleration for the other one.
Right.
And even if we make the hardware ray tracing 100 times faster, there is still this shading part that can be a bottleneck. So we focused on optimization, on optimizing this part, so that we can get actually to the actual real time here.
Right. So the RTX hardware is really designed for the ray shooting part, right?
Yes.
So if you have no shaders or just one shader on it, it'll go ridiculously fast, right?
Yes. The simpler the shader, the faster the rendering goes.
Right. Complex shaders like subsurface scattering or things like that, those are a bottleneck.
Yes, absolutely.
Right.
But on the other hand, there are many things that you can do with ray tracing only, like soft shadows or image-based lighting, or simple refractions. Pure glossy refractions, or specular refractions.
Right.
Even blurry reflections are also up there, depending on how you approach the methodology, the rendering.
Right. But okay, so a couple of things. What is the advantage of going fully ray traced as opposed to keeping some of it rasterized.
Yes. I realize we didn't talk about that a lot,
Right?
Because here internally in the company we know that ray tracing is going to always give you the best result, and quality is always going to be good, and this is kind of implied, but expected. But the implication of that is also that. And I have to go back a little bit here.
Sure.
Typically, going into real time involves switching the render paradigm, so to speak. From ray tracing offline rendering to real time rasterization.
Right.
And because rasterization has different shortcomings, like no secondary effects, or because it doesn't do ray tracing, there are no indirect effects like shadows from an object that is outside the camera frustum, or reflections that are not visible in the screen area,
sure,
in the screen space. So all kinds of workarounds or different algorithms that were meant to fix those shortcomings were invented, like, for example, shadow maps
and reflection cubes and
reflection captures, or cubes, or environment mappings with different methodologies, or not algorithms, but
it's a lot of hacks.
Yes. Well, I like to sum this process up of calling it prep work, or data preparation work.
Right.
Typically, when you go into a game engine, or any kind of real time sort of engine, you need to take your current data and then try to think about all these additional effects that you want to include in your scene, because they're not enabled by default. They're not going, or they're not popping up. So you need to do all these additional modifications, like placing the reflection cubes here and there, and decide if it's going to be
pre-render all the shadow maps,
a sphere. Well, there are ways to make it interactively performing.
Sure, but you're rendering separate things. You're rendering a shadow map, and then you're rendering.
Yes. Typically, the engines render the shadow map by themselves, or, on their own, automatically. But then there are because it's not automatically generated effect. It's a different projection with its own settings. So if you want, for example, more detail in the contact area of the shadow, you need to tweak the light settings to get sharper shadow.
Sure.
Or if you want to make the shadow a bit more transparent because of the indirect bounces of light, you need to simulate this by again adjusting the transparency of the shadow, and so on and so forth. Which ultimately takes a lot of time, artist time. Which is the more I'm just going to say it's the expensive part. I mean, computing power is relatively cheap, but an artist, a day of artist's work is just a waste of many hours.
Which definitely makes sense when you were talking about the offline world, where it's like, it's okay, we'll deal with the time on the rendering side, but the artist time is smaller, right?
Yes.
But when you demand real-time performance, rasterization was the only solution, because at the time, right?
Absolutely.
So now you can get both, right? Well, so ray tracing is, you don't have to hack it because it's accurate lighting. Is that correct?
That's the premise. Yes.
Right.
Absolutely. Because it's basically optimized simulation of the physical world.
Sure.
Because in the end, light behaves in this way. Photons are being, bouncing around in straight lines, and they are just transmitting energy.
Right.
Which in our case is color information.
Right.
With rasterization, it's not the case. That's not the case.
Sure.
You have to work around, or cheat, or add on top of it, so in order to simulate the same effect.
Right.
With ray tracing, the premise is that we're doing calculations the same way as light would. Right. However, instead of calculating, I don't know if I can come up with a number that is realistic enough, billions and billions of photons, we're calculating just a smaller amount of millions of rays. Or using this information to come up with a photorealistic solution.
Okay. Now I want to do a couple of comparisons compared to what other things are going on. So there are people that have been using the term like, oh, this is ray tracing, but this is path tracing. Like, I think these people are getting a little confused. It's all ray tracing, am I right?
Absolutely.
explain those differences. Like, what when people are talking about path tracing versus ray tracing, what do they mean?
Essentially, it's very interchangeable, especially in the case of the renders that are using ray tracing.
Sure.
Very to a large extent, most of the times it's interchangeable. Ray tracing is the fact, or is the method algorithm that takes 2 points and shoots a ray between those points and traces for intersection along the line.
Right.
Or not 2 points, actually 1 point in a direction, and then
see if it hits something.
Right, absolutely, if there is a hit. This is the ray tracing.
Sure.
While path tracing is using ray tracing as a method to construct a specific path of the ray, and this is why it's called path tracing, because it's not just a simple point in direction. It's there is a path that we want to follow. Right. And this path is from the camera to the light source, typically. Because now we have two important things, because in the ray tracing you don't have kind of importance stuff. It's just the process of generating a point in a direction and see what's going on in this direction.
Right.
While with the path tracing, we know that for rendering, we care about lights, and the path of this light
you
photo.
Favor array that looks at lights.
Absolutely.
Right?
Yes.
So really, that's important sampling is another way of doing that thing.
Yes, it's a term that is widely used in the computer graphics programming, importance sampling, which means actually that, sampling is another way of saying that you're ray tracing. Technically, sampling could be used also for looking at the pixel of a texture on a surface, or looking at the specific color of some triangle or some area. But again, in our case, we can fairly easy interchange sampling in the favor of exchange or equalize the two terms, because again, when we're calling sampling, it most likely involves shooting a ray and finding the intersection of this ray and checking the color there, and the checking part is called sampling, but it implies again shooting a ray.
Right.
And why is important sampling? Well, because we know some things about the scene. We know where the light source is. We know where the camera is. So we're kind of more interested in some paths more than others. And this is why we call it importance, because we know that these are the important areas.
Which is why we're biased. Right?
Yes.
And that's a good... people like to say unbiased is better, but it's not, because I like to call it unsmart, right?
Right. That's a good one. Yes,
right?
Absolutely.
Because biased rendering is like, I know that these rays are more important to samples, so I'm going to favor those. So, right?
Well, there are two ways of looking into about unbiased rendering, and one is like grouping the rays into different rendering aspects or material aspects, I would say, like diffuse and reflections, or specular reflections and refractions, and or maybe let's talk about reflections. The reflectance can be in physical world. Reflectance is one aspect is the phenomena of light hitting an object and bouncing off of it, rather than going inside of the object, which is transmittance.
Right.
So the reflectance of glossy objects can be very easy to calculate, because there is no dispersion of the bounced photons. They keep their parallel, so to speak, coherence, if you will. While on more matte objects or blurry objects or diffuse objects, the rays reduce their coherence, and they're dispersed all around. So if you want to calculate these diffuse objects, you will need to calculate many rays in order to make sure that you're not missing any part of the environment and the reflection looks okay.
Right.
However, this requires many rays.
Sure.
And the biased renders figured out that there are mathematical ways to approximate this lighting without actually calculating many rays.
Right.
And this makes it biased.
Right.
Or smart, as you say, because you don't need the result in the end is giving the same image. However, for one of the in the first case you weight a lot more.
Yeah.
While in the second case, the biased one,
right.
the smart one, the important sampled one,
yeah.
is you're weighting much less because yeah. And here, by the way, mathematics comes into play because there are mathematical ways to prove that the two results are going to be almost identical.
Yes.
Or identical.
Yeah.
And there is no need to waste performance on this.
Right.
However, the unbiased renders, I believe, were very popular at some point, especially with the notion that you're performing physically accurate or no, I don't. Let's not use this term because it's
right.
associated with other stuff. Scientific, let's say,
sure,
a plausible result. And if you want to simulate the light, as accurate as possible,
right?
As if you're in a physics lab and doing optical research,
yep.
Then you need unbiased render,
right?
And one can argue with that again, because having the mathematical proof that the two results are going to be identical, depending on your purpose, of course.
Yep.
So if you're not rendering or measuring outside of the visible spectrum, you're good to go. I mean, you can use all the biased approaches that you want.
Sure. Well, that's good. We are on a bit of a tangent there, but that's okay.
Yes.
I do want to, talk about a little bit. There have been obviously some rasterized solutions that are, trying to alleviate a lot of the problems that rasterizers have. And I remember this back in the early 2000s in the offline rendering world. There was all these little hacks and tricks that were added to them to make things that are basically unnecessary if you go full ray tracing, right?
Right.
So solutions like in Unreal 5, when you have things like nanite or lumens and stuff like that, those aren't necessarily ray tracing solutions, but they're solutions that help it try to make it look like it is ray traced. Is that true?
Yes. Partially.
Okay.
Yes. So nanite is a technology that actually handles polygon rendering or triangle rendering.
Yeah.
In the rasterization pipeline.
Yes.
And it handles massive amounts of data, or it's optimized in a way to stream the data very efficiently and display many triangles.
Which has always been a problem for rasterized rendering.
Yes. Well, due to the nature of rasterization, it requires a lot of sorting of many different vertices and triangles, and this has a bottleneck. I mean, it can be really fast up to a certain degree, but then once you go over this threshold, it starts becoming really slow.
Right.
And that was one of the shortcomings of all the ray tracers, rasterizers, rasterizing engines. So nanite was going for this for the solution of this to
because people had to optimize their scenes, and that's again another overhead that's very expensive.
Well, the term LOD, level of detail, comes from the gaming industry, which was exactly that, optimization of the number of triangles of your object, so that when it's not close to the camera, you don't render the full number of polygons, so that you can be below this threshold of the bottleneck of the rasterization. So nanite was a solution for that, or is the solution aiming to solve this problem. So it's not necessarily connected to ray tracing. Lumen, on the other hand, is a GI and reflection solution, which arguably uses ray tracing.
Arguably.
I'm going to say arguably because it uses under the hood, it uses approximation of the scene rather than the actual actual representation of the scene. So when, for example, you look at a reflection or the object that is used for reflections or GIs, or GI rays or soft shadow rays for in the engine of Lumen,
right?
Is actually not the real or not the author edited object. It's an approximated version of this mesh.
Sure.
And it's actually not even a mesh. It's something called mesh distance field, or a voxelized version of the mesh.
Voxelized version.
Right. So it's a really ingenious method to make it possible to render these type of effects in real time. But again, you're losing quality.
Sure.
Also, if the result is not good for you, or it doesn't look good for you,
right?
Then again, we're back to the process of manually tweaking, finding the appropriate mesh that doesn't look good, for example,
right.
Tweaking its mesh distance fields or recalculating that. It requires again additional number of steps to kind of figure out what's wrong with the scene, or what can be improved with the scene, and tweaking it. Hence, artist time. Again, artist time. Also, due to the nature of Lumen is just one aspect of rendering. Again, it handles GI and reflections.
Yeah.
So for the other parts, like let's say shadow from the sun, or shadow from dynamic shadows from lights, or anything like that.
Right. Direct lighting.
Direct lighting. Yes. You still need to use the other engine.
So it's an engine on top of an engine on top of an engine.
Exactly. And the combination of these features requires somewhat deep understanding of the different rendering paradigms.
Sure.
And how to mix those. Like for example, when I get closer, I want to turn on let's say ambient occlusion to get better detail, but I don't want to spare the ambient occlusion for objects far away. So you need to tweak things for the camera.
A lot, yeah.
Right. And I'm not saying that this is not a feasible solution.
Right.
It's perfectly valid option. We see a lot of results.
To me, it sounds so familiar to about 2004, 2006. Working in RenderMan, where you'd add all of these things on top of things on top. You had to render reflection occlusion, ambient occlusion, everything just to try to actually get a render out that looked plausible.
Right.
When you could have just ray traced the whole thing and not have to worry about it.
Right. Well, and that's always the two camps in rendering. Do you favor artist time or machine time?
Right.
Or ease of use? The time you need to set up the thing,
sure,
or do you need to save computational power in some way? And if performance is your goal, again, real-time engines were the go-to choice.
Well, in the game, yeah.
Yes.
Right? You can't say, it's fine. I mean, gamers want to have 60 plus frames per second, right?
Absolutely.
And so you're not, until recently, you were not really possible to do that, right?
So of course, yes, and because of that, it was the rule. If you need more than 50, 60 frames per second, you have no other choice. You can't. Actually, until recently, you couldn't even think about 10, 20 frames per second with a ray traced,
fully ray traced
solution.
Yep.
There were some experimental render engines that were capable of outputting fully ray traced solution, only on clay materials, grayscale materials, with only one bounce of light. So this was not a realistic scenario. They were just experimental stuff. And but if you really want to use it in production, it was a no-go.
Right.
And again, this was why it was very, very exciting when we finally had this, massive corporations like Microsoft and NVIDIA working together to finally solve the ray tracing, hardware ray tracing problem.
And we have, so we created Lavina. It was called Project Lavina, right? It was our tech demo, but we still call the renderer under the hood, we still call it Lavina, right?
Yes.
Right, so Vantage is a package that uses Lavina as a renderer,
correct,
right? Lavina, by the way, people should know means avalanche in Bulgarian. Is that correct?
Yes, it is.
It's an awesome name. So great. So when we created this thing, we created this renderer, Lavina, and then we created Vantage. When did the first version come out?
2020.
2020.
20.
Okay.
Yeah.
Okay. So, and it's a standalone application, right?
Mhm.
So let's just a quick overview. How did Vantage come out? What did it do? Now that we have a good idea that it's using this very robust renderer, right?
Right. Well, Vantage is an application that wraps around or uses the Lavina renderer,
Right.
but it also builds upon with functionality that we wanted to make use of the fact that we have a real-time ray tracing engine.
Sure.
So the first thing we kind of built upon was with Project Lavina. In the start, it was the render engine with a little bit of Chrome around it, just to be able to do something with it.
Right.
It was essentially a scene viewer.
Right.
And Lavina was designed to work with V-Ray data. So
with V-Ray data.
With V-Ray data. Well, this is the render we have in house.
Right.
It went through the beaten path. We know how to do rendering
Sure.
or ray tracing there. We just did optimizations to make it faster.
Sure.
On the hardware.
But also, Lavina is real-time first, right?
Yes.
That's its priority. V-Ray is as many features as you need.
Right.
Right. And Vantage is as fast as, or Lavina is as fast as you can go.
Yes,
right?
this was the concept.
So in order to do that, there are certain things that Vantage or Lavina doesn't do, right? It doesn't render subsurface scattering right now, for example.
Yes.
Right.
Yes. So we want to make it useful as useful as possible to everyone that's out there that wants to use this or real-time ray tracing. But when we were thinking about the features we want to implement, we are always cautious about the performance hit.
Sure.
And because, as you said, Lavina Lavina is real-time first.
Right.
And of course, it's very vague when we're talking about real-time. Let's say we're kind of locking or the threshold that we have for calling something real-time is 24 frames at HD.
Right.
So if we can, sorry?
Or better.
Or better. Of course. But if we pass this threshold, we say that we're in the realm of real-time.
Sure.
Lavina is still real-time first, and then adding features that would make it useful to the artists, and any new feature that will be that we think of adding goes through the process of evaluating first how much the performance is going to be affected,
right?
Testing it out, because sometimes sometimes the initial considerations may be slightly different.
Yep.
And depending on how much performance we gain, we lose or gain. Typically lose.
Mm-hmm.
We start looking into ways to optimize it.
Sure.
We have really good developers here that are always cautious about this aspect. Any new feature that comes into Vantage is again subject to a
scrutiny,
thorough scrutiny, optimization first, and then if the frame rate is not affected, usually we have this kind of rule. If the performance drops more than 5% with this new feature, and there are no optimizations that can be done, this feature is not going to make it in the build. Of course, these change with the generations of hardware.
Sure.
Because every new generation introduces...
So once you can get the performance up, you can add features to still get to that 24.
Absolutely. Absolutely. Or more.
Yeah.
And this makes it a bit difficult again, because we have not only different generations but different tiers of hardware. It's really funny. One thing that we noticed with the last generations of GPUs is that there is a huge jump between, for example, the flagship model and the one below it, like 4080 and 4090.
Big difference.
There is a big difference in both in spec and naturally in performance.
Right, and price.
Of course. Well, it's deserved.
Yeah.
That's what I want.
Right.
That's what I want to mention. It's a well-deserved price. You're getting really beastly performance out of the 90 version. But that wasn't the case with the previous generation, or it wasn't that large of a difference between the...
Right, so like a 3090 and a 3080, there weren't as much difference.
Yes.
But the 400 series is much bigger.
Yes. And I think this is because that was also noted by the notation, because the previous version, they had a 3080, 3080 Ti and then 3090.
It's all confusing.
But what I wanted to, why I mentioned this is that we're talking about performance, and it is very subjective based on the device that you're having.
Sure.
And generation and tier of the device that you have. And to make it even more complicated, the newer generations add new capability. Right, like new features that are specifically designed to speed up ray tracing again, or adding different features that are going to help only the latest generation, which is only natural. This is what R&D is.
Right.
NVIDIA are outputting new stuff and they have to come with the new hardware, of course.
Sure.
Cannot be some things can be backported, but sometimes it's software emulated or partially emulated, which means that they're not as performant as possible.
Right.
But it's still you can use it. For example, that was the case when Vantage came out. Officially, we supported the flagship from the previous generation before RTX, the 1080 Ti.
Oh wow!
Pascal, I think it was the generation. So we did support that, although Vantage was running much slower there. And at some point, we wanted to add new features that were only available for the RTX devices, so we deprecated this feature. And by the way, this feature is denoising.
Okay.
So one thing that I remember we were talking about rasterizers and ray tracers. One of the real big difference that also made fully ray tracing possible, or actually ray tracing possible on the hardware in real time, is denoising actually.
Right.
Because with the power of the hardware acceleration, you can get a clean image in a few hundreds of samples, like 200, 300 samples. You will be able, depending on the scene, of course, of the project, you can get a clean image out of it. But still, this costs, or you need like a couple of seconds to get there, even on the most powerful GPU.
Sure.
And if you want to have multiple frames per second rather than multiple seconds per frame,
right? Yeah.
If you want to switch this around, you still can't get this in time, especially in more complicated scenarios like indirect illumination, interior lighting, and so on.
Right.
So denoising is a big part of that, and of course denoising has been on the horizon, being developed by multiple companies, not only NVIDIA but also Intel released their
denoiser,
open denoiser, which we included in the last iteration. Yes, also a lot of different versions are there, and
most of these denoisers now are trained, like AI denoisers, right? So
absolutely.
So they're trained to know, like, based on this, I know that this is what it should look like, right?
Absolutely,
right,
absolutely. And this is a huge deal, by the way, because and that was also somewhat of a coincidence. When the hardware accelerated GPUs came out, they also had not only a part of the chip dedicated to ray tracing, but also another part of the chip which was dedicated to AI.
Right.
Right, and it was funny because artists wanted to get those GPUs to render faster,
Yep.
while other companies that were using AI wanted to get those cards for training,
for training, yep.
training AI, and that was also a hit on the market, and artists couldn't get those GPUs.
Right.
Yeah, but that was a good part because all of this training resulted in
really good denoisers. Yeah.
Really good denoisers, and now the new generations make even more use of the tensor cores. So
awesome.
the AI dedicated hardware.
I want to get back to Vantage though. So Vantage is a package because I want to get to Vantage 2 because it's a big deal. So by the way, I should mention I'm very biased towards Vantage. I love it because of its performance, and being a complete ray trace freak myself, the fact that we can actually ray trace at this speed is amazing to me.
Right, yes.
So, but Vantage really, you thought about it. Okay, now that we can take our V-Ray scenes and bring them in and see them in real time, you added some features to Vantage to allow you to make it very useful. What were some of the features that you added? First Vantage. We're going to get to the second Vantage later.
In first Vantage, right. Well, we built on top of the scene viewer, so to speak. So we allow the user to manipulate parts of the scene.
Mm-hmm.
First, of course, get data. One of the important things to render out something is to get the geometry, get lighting, get materiality, textures, and everything. So this is why, by the way, we're using the V-Ray scene format, because it encapsulates all of this data, even animation.
Right, but it's pretty quick. You can be in 3ds Max or in Maya or Houdini or whatever. Anything that can output a VR scene file, just output it and drop it into Vantage, and it's there.
Absolutely, yeah. and this was required because, again, Vantage is a standalone product that's required to be run on its own and consume data from somewhere that came out of somewhere. So obviously this introduced a bottleneck in the artist workflow, because every time you want to see your V-Ray data, you have to export, save it on disk, and then import, which is another iteration in the whole process.
Right, but it doesn't take that long, but it's still a bottleneck.
Yes.
Right.
And one of the major features we added in version 1 was something we called Live Link, which utilized the distributed rendering and the interactive rendering aspect of V-Ray, which actually interactively exports a scene in memory, and it updates it every time the user changes something.
Right.
And we just read this data from memory.
I mean, it's similar to what we were doing with V-Ray RT, right? When we were doing V-Ray in the viewport with
kind of.
Any scene state that changes, Vantage sees that scene change and updates it on the fly.
Absolutely. That's the interactive part.
And it's so you can be in Maya and you hit the live link to Vantage, and then you just Vantage is rendering what you have in Maya, right?
Yes.
Right.
Sorry, as much as possible.
Right.
We realized that at some point that would be a bottleneck, because you say when you said that the V-Ray scene export is fast, that's true.
Right.
But if you are doing look development, you're going to constantly be changing slightly some parameters and look for the result, and you don't want to do that all the time.
Sure.
So in a many iteration process, this becomes actually it adds up.
Right.
And what you described was actually the solution to this process, because we wanted to keep Vantage as a standalone product, not injecting it as part of as a plugin, for example, in Maya or Max or any other host. We wanted to keep it standalone, and there is a reason for that. I'm going to come back to it. So we just leveraged the interactive part of V-Ray and the fact that it's a V-Ray scene data that we know and understand. And you just run Vantage on another monitor, or we have also always on top screen, always on top mode that you can place conveniently on one of your viewports, for example.
Sure.
And kind of pretend that it's part of the process there.
Sure.
We wanted to, and yes, everything you do was immediately exported or represented in
updated in the scene.
Updated in Vantage.
Yeah.
The funny thing was that sometimes, for example, and that's particularly true for 3ds Max, when you're working with a heavy scene, lots of polygons, lots of objects, and do some change, the viewport of 3ds Max now becomes the bottleneck because it's a rasterizing engine, and it takes time to update the viewport.
Right.
But the data gets to Vantage before the viewport updates.
I've seen that.
And you see the update faster.
Vantage is rendering faster than a rasterized render. Yeah.
Right.
Yeah.
That was funny. But yeah, and this is why we wanted to keep it standalone, because when we have Vantage running as a standalone, we have all the control for performance.
Yes. You don't have to deal with some bottleneck that you have no control over.
Absolutely.
Right.
Yes. Because we're limited to the API of the host.
Right.
And whenever the host finishes processing the data, then we can get to it.
Sure.
While in the other case, we just take the data first and then render it as fast as we can.
Yeah. But Vantage was, the first Vantage was really cool. You can do some walk arounds, you can move lights around, you can change the sky, you can change some LUTs, which was a really cool.
Right.
You even added some post processing like lens flares and blooms and stuff like that. And it's really kind of a nice thing. And the nice thing I liked about it is that it could do all the things that I loved about ray tracing. It could do truly accurate depth of field. It could do all kinds of really pretty things.
Right.
And you even added a little bit of animation support just to do like simple walkthroughs or simple sweeps and stuff like that, right?
Yes. Well, because again, we allowed exploration of V-Ray scenes or any scenes actually.
Right.
Because Vantage does support other 3D formats, but most of these formats don't have materiality.
Sure.
The materiality aspect. So it's better to use V-Ray scenes.
Right.
We allow the user to just walk around and freely without the bottleneck of performance hits or so they can just start looking around and find viewpoints.
Right.
And then when they find their viewpoints, they can experiment with lighting or
much
objects.
quicker than they could have done it otherwise.
Right.
Right.
Absolutely. And in the immediate moment you change something, you see it ray traced, which means you see all the effects or all the aspects or all the visual quality that you're used to with ray tracing engines, but in real time.
Right.
And that actually enhances creativity. We saw many artists actually feeling freed or liberated by the fact that instead of waiting, moving in a rasterized viewport, which doesn't have any shading information, or even, we know that currently the viewports of the GCCs tend to have better looks, better modes that show a better image, but then their performance drops even more. So if you have a couple of millions of polygons, you can't use those modes.
Right.
You switch back to wireframe or flat shading, and again, you don't see anything in this viewport. There is no question about it. But typically the workflow is manipulate something in the viewport and then do a reference render to see what it looks like.
And you have to do version after version after version.
Or use interactive rendering, but the interactive rendering, again, as we said, the host becomes the bottleneck. It needs some time to pass it down to V-Ray, for example. And then V-Ray, because does all the shading possible there, it takes a bit more time. It's not real time. It takes a few seconds to convert the image. So and all this is removed when we're working with Vantage, and then this makes you, when I like to compare this by when your brain works faster than when you can write, for example, and you can miss a good idea just because you're not capable of writing it that fast or sketching it that fast.
Sure.
This is very similar to that. You can lose some inspiration or
I sort of look at it
momentum.
as, before you have to do version after version after version after version to get what you need. And here it's like you have infinite versions that you can look at with the mouse.
Exactly.
And then you decide which one you want when you remove your finger from the mouse, right?
That's a perfect example.
Yeah. Yeah. So I think it's much, and so you basically, this decision tree that you're going through here could represent hours and hours of versions that you would have tried earlier.
That's absolutely true.
Right.
And we even know that in more complex scenes, people tend to, or artists tend to render regions just of parts of the scenes to check out how this, in order to speed up the process.
Yeah.
So
they make sacrifices. Yeah.
They make sacrifices, absolutely. Yeah. And in the case of Vantage, they're making sacrifices of features. Yeah, because we don't support subsurface scattering, as you said.
So, as an example. But there's a lot that we can ray trace without needing subsurface scattering.
Yes. No, when we released Vantage, again, it was called Project Lavina, and then we announced public beta, and then the first version of Vantage, and people were experimenting with it. We had tens of hundreds of requests of getting those features that we didn't support. And as time went by, people kind of forgot that they needed these features. Not everyone, of course. There's still missing features like displacement, which we're working on.
Right.
But the subsurface scatter or hair and fur, kind of got forgotten. I mean, we still have occasional requests of getting those back, but essentially, you can make a decision about your scene even without the grass or without the fur on the character. It would be nice to have it, of course.
Sure.
But for lighting, for shadows, for the majority of reflections and refractions, you don't actually need this to make a decision.
Sure.
To do your light setup.
Yeah.
So this kind of got forgotten, and also we figure out saw that many people were willing to sacrifice rendering features in order to get to the faster rendering, because they realized. So, getting back a little bit here, we because we knew that these features are actually requested features and needed for production, and we knew that we didn't support them. We kind of said to everyone, you can use Vantage for look development, but not for final rendering because it doesn't support these features. So you can use it as a really quick preview render, or a really quick look development tool, and a really accurate pre-visualization tool.
Yes.
Because again, if you sacrifice the short fur on the character or the short grass on the floor, which doesn't change the shot that much, you can do a pre-visualization that has everything else.
Right.
And
at a much higher quality than you've, or closer to the final version than you've
absolutely
had.
Like 80% there, 90% there. Pick a number here.
At a substantial speed increase.
Well, real time.
Right.
Yeah, we had a lot of customers, and I'm going to quote here, probably a bit wrong, but Vantage allows us to art direct our projects in front of the customer, their projects in front of our customers.
Right.
People tended to do this over the shoulder presentation, and that actually coincided with COVID. So people had to do it over
Zoom
or whatever. So they just share the screen, and they literally said that something that used to take a couple of days of iterations, back and forth via emails or calls and whatnot, took 30 minutes. Just 30 minutes, they were discussing everything in real time. The client feels really, really satisfied with the way they can just say, okay, can you move this here? Can you change the lighting? Can you change that? Can you change that?
Make this red, do this.
Yeah, apply a different material.
Right.
And this was done in 30 minutes, and their job done.
Yeah.
Saving multiple iterations. And again, because you don't need this artist preparation time to do it every time in real time, you're just saving a tremendous amount of time.
Yeah, and I think you're right. I think that this is something that the Previz world could definitely take advantage of more, and should be more aware of the fact that this exists. Because people used to do play blasts and stuff like that, and they looked okay, Or a lot of times right now they're using other rasterized solutions that that look pretty good or look nice, but it takes a huge amount of prep to get there, and they have to do all this stuff. If they can just use assets that are the same that they're going to use in the final version, right, and use shaders that they're going to use in the final version, then it probably can get a lot there.
Yeah, absolutely. This process is associated with a pipeline pressure, so to speak.
Yeah,
which with using the at least with fully ray traced solution, it just goes away.
Right.
And especially with the combo of V-Ray and Vantage, because we use this data authored for V-Ray, you don't need to change it at all. You just alter it for production, preview it in Vantage, and you can always go back to production and output the high quality that V-Ray is associated with.
And you don't have to manage polygons. You don't have to do all this.
Well, there is a footnote here. A footnote here, which is if you have enough memory.
If you have enough memory.
Yes. And
but these cards now, they get a lot of memory in them.
Right. We're doing all kinds of optimizations to kind of cater for the memory demanding scenes, because the golden rule is, or the famous rule is that you do optimizations, you make more space or more performance for the user, and then you give it to the user, and then the user expands their scenes twice or demand. They will always find a way.
There's a name for that. It's called Blind's Law.
Blind's Law. Okay.
Yeah, it's like Moore's Law, but Blind's Law is like basically that render times never change, because every time you increase performance, you just add more features.
Right, exactly.
Okay, so I want to make sure we get to Lavina 2, because that's an important part of what we need to discuss. So a lot has changed, and a lot new things have been added in sorry, not Lavina, Vantage 2.
In Vantage.
So what's new in Vantage 2?
Yeah, right. Well, when we figure out that a certain amount of users are willing to sacrifice features,
right?
Like hair fur and stuff like, and subsurface scattering, to use it to get to the faster rendering,
right?
They were using Vantage for production rendering,
right?
Yeah,
in certain cases,
and that was actually a surprise for us, but not a huge surprise, but the surprise part was that people were willing to make the sacrifice in order to get to the faster render times. And we've seen many comparisons that, for example, in order to get a decent looking image with for a certain scene, in V-Ray, for example, or Corona, you need to render like 5 minutes per frame. While in Vantage, you can render with 30 seconds per frame, again using denoisers and sacrificing this quality. The features that can give you this quality,
so you can use Vantage as an offline render to get bigger, higher quality images. Right?
Yes, because still Vantage is a ray tracing engine in the end, and it accumulates samples, which means that as time goes by, it's a progressive rendering.
Right,
you will get better quality.
Right. So
it's just that because it's faster, you have to wait less time than in another offline rendering solution. So one thing that was really very popularly demanded was so when you go to production, one thing that is typically associated with production is post-production.
Yeah,
and people wanted more of those features. So that's why we added more post-processing color corrections and post-processing effects directly in Vantage, so that you can kind of use it for final frame rendering.
Right.
But also, if you wanted to go into a separate path for post-production,
like for compositing,
tool in compositing, we needed to get to render elements, or AOVs.
Right. So AOVs have been added too.
So this was one of the biggest, one of the big things coming with version 2.
Nice.
We also and we couldn't add all of the render elements or AOVs that
but we added
were available.
As many as we could for now.
Yes. And we even added some masks and utility ones like bumps and Z depth to get more back in post. But one of our premises here for not adding all of the render elements was that we want to again go back to Vantage being a real-time solution, and by being a real-time solution, it saves time, and we wanted to keep everything as much as possible in Vantage. If you can complete your work in Vantage, this means or actually, I'm going to say it the other way around. If you go into post, in compositing for doing post-processing or anything else, it's another iteration or another step in the process, which requires saving to disk, loading it to disk, performing the operation, and again rendering.
Right.
So we try to kind of reduce the amount of these, the need of going forward in post-processing. But of course, there are always things that you can't foresee, like, for example, selective color grading, because the customer wants, I don't know, more color bleed or less color bleed or more reflections. So this was one of like the fail-safe or the backup mechanisms for you finish everything in Vantage, but in case you need to do some minor color correction later on because of the client request, that was one of these features. Another solution that or not solution, but interesting, exciting thing we added was upscaling denoising.
Yeah.
So the NVIDIA AI denoiser actually allows for upscaling since a couple of versions ago, and we introduced this, which basically means that Vantage can render at a quarter of the resolution. And the resolution is by far the most performance impacting factor. And then the AI denoiser upscales it and denoises it at the same time.
Right.
So
and we've seen this in games. They've added these upscalers in games before.
Right. Yeah. DLSS and is the one that NVIDIA uses, or the proprietary for NVIDIA.
Yeah.
So we were experimenting, by the way, with DLSS as well, but the NVIDIA AI denoiser proved to deliver better results.
Yeah, because it's a ray tracing problem, right? It's different than a rasterized problem.
Exactly.
Yeah.
Exactly.
Gotcha.
Right, but probably it's a good place to mention that we're looking into R&D and constantly looking into finding more solutions. So we think we're going to find a much better solutions out there as we speak, because age of the AI.
yeah, of course.
Another thing that we added was also again popular demand. That was a request. That was render time subdivision.
Render time subdivision. Okay.
Right. Getting a low poly model and smoothing it out. But the render engine does that. You don't need to perform it.
Okay. So this is going to lead eventually to displacement.
Exactly. That was the first step.
Yeah.
And as I said, we are working on displacement, which is the second part of this process.
So that's exciting. Yeah.
Absolutely. Yeah. But not there yet.
But we got the first part figured out.
Absolutely.
Good.
Yeah. Another interesting thing that we added was the scene states, which allows look development or experimentation and also presentation of your project.
Right. Well, you've added much more of these sort of like here's a state of the scene with the lighting, and you can. So the interface itself has added a lot of these ideas as a presentation tool.
Correct. Yeah. Because one thing we kind of noticed was, again, remember the 30 minutes over the shoulder presentation thingy. So Vantage was used both as a viewport companion by the artist, working interactively, and they're previewing their scene in Vantage with all the bells and whistles of ray tracing. But when it comes to showing their work, they still needed to pre-render stuff and show it to the customer the traditional way. But now with the real-time thingy, they just with the real-time ray tracing, they just took Vantage, placed on another monitor, and they continue working in Maxima or whatever, just letting the customer see only Vantage, and use it as a real-time reference monitor, so to speak, or a presentation tool. So to make this easier. Or one thing that they happen to get asked a lot was do changes in the scene, because the customer or the client always wants to see to be kind of like a director and see different versions of the scene, different changes of the scene.
Right.
Or alternatively, when preparing for a presentation, the artist has a story to tell, typically, and for that story, usually this requires different light setups, different combinations of the scene.
Yep.
We've seen many times users saving different Max or Maya scenes and reopening them, rendering them out just to tell the story.
Right.
It's essentially the same project, but optimized for different views, for different light setups. So we set to try to find a solution for that within one scene.
Right.
And we figured out, okay, let's make this entirely in Vantage because it's going to be much, much faster. Some tools don't have the same, or some hosts don't have the same functionality. Like, for example, SketchUp or Rhino don't have the functionality to change the whole aspect of the scene with one click.
Right.
So we implemented that in the standalone version of Vantage and allowed every user to take their data, import it in Vantage, and create states.
Right.
But these are not states for the scene. We split those states in different aspects. You can create different lighting scenarios. You can create different material or combination assignments scenarios, visibility of objects, transformations of objects, post-processing states, whatever you wanted.
Right.
Or I think these were the most ones.
Sure.
But then when you create different cameras, you might want different lighting scenarios. That was actually a very requested feature, binding the scene to a camera. Because when you create, let's say the most common example is the ArcVis example, where you have a shot from the ground, looking up to the building, and you want to see, for example, the reflection of the sun or the clouds in the glass and the facade, and then you set up the environment and you make your camera portrait with portrait orientation, probably 2-point perspective and whatnot, and then you have a birdshot, for example, and then in that birdshot you want the sun to be straight down or casting or maybe sunset condition where there are lots of shadows, long shadows, just to make your story, or even a time lapse.
Right.
So all of these now can be achieved with the scene states by assigning different conditions per camera. And I like to think of this because you can have hundreds of cameras in your scene. I compare it as a 3D interactive PowerPoint, if you will, because your cameras can be your slides, and then you can apply different
but
styles.
with each camera, there's a new state that you can apply to the camera.
And I think of these as the content of the slide or a layout of the slide, where you're finding different things. But the good thing is that instead of, and you can totally do this with the traditional way by rendering it in advance, but then you're fixed to what you've rendered. While with Vantage, this is an interactive session. So at any given point, while you're presenting your story, the customer, the client can say, okay, but I didn't get that, or can you change this?
Yeah,
can
but I want the shadow over here now.
You can immediately just branch off from your presentation and start navigating in the scene, changing the scene, whatever you want to do. You can do quick snapshots out of these. And send them to the customer to get, these feedback sessions become much, much more powerful this way.
Yeah, it's very interesting. But let's talk a little bit about like PlayBlast, because I think that especially in the Previz, and even in terms of ideas of virtual production or anything of that nature, but how you've added some things that make getting a quick animation PlayBlast much easier in some ways. So explain a little bit that process.
Right. So the major thing that was stopping good animation previews was the lack of animation support. So version 1 of Vantage has support for transformations only. So if you had a character or deforming mesh, something that changes vertices or polygons in respect with each other, that wasn't supported in Vantage. So we made sure that this was now supported. Also, if you had any kinds of animation outside of transformation, meaning materials changing their parameters or lights changing their parameters, that was also not included. I mean, the transformation of the light was included, but if you want a strobing light or changing the color of the light, that wasn't supported. So we made sure also we supported that one as well. And also image sequences being used as textures. People wanted to have, LED screens or fireplaces or you name it, or water based on normal mapping and whatnot. So we added support for those. And with that, we enabled kind of two workflows. We call them Previz and PlayBlast, which essentially is the variation of the same thing with different focus. Okay. The PlayBlast term is typically associated with the Maya and the animation artists doing PlayBlast of their characters, while we wanted to kind of, because the PlayBlast is actually rendering of the viewport, and you can use it also for cinematics or animatics or Previz from the camera as well. But because that was a slightly different use case, we kind of wanted to use a different term for that, which we called Previz. So basically, we have an example on the website or in also in our YouTube channel. But if you're an animator doing your PlayBlast, we know that Maya can or Max or any actually animation software can drop frames. So you're typically doing the rendering of the viewport so that you can ensure there are no frame drops and a consistent frame rate of, let's say, 24, 30 frames per second. And you can make a judgment for the animation itself, the motion itself. And the quality of the viewport typically is enough for that because you're looking at the animation actually, not the rendering part.
Yeah, but you want to see more.
Absolutely, and we have some examples of how different lighting conditions may actually change tremendously the way the animation looks like. And now we have enabled this the workflow that instead of waiting. One addition here: typically the PlayBlast, because they're rendered, take a little bit of time. So usually the artist kind of starts a PlayBlast and then checks their email or get a cup of coffee, or takes like a 2 to 3 minutes depending on the And we measured that on more complex scenes, it can take like 2 to 3 seconds per frame for the PlayBlast to complete.
That's right.
So we set up the same scene with Vantage and set it to render for 2 to 3 seconds per frame, and render the same PlayBlast. And the difference is night and day, literally, because we animated the sun cycle to have night from day. And but anyway, I mean, you get the same render time, but totally different look.
Much better
look. You can make decisions about how your animation is going to look in the final shot in the and that's on the animation level, on the animation artist level. Now if we go larger and take a look at the bigger picture, the previsualization part is typically involves both animations of the camera, the whole geometry, if possible, the whole scene, the everything, and the whole shot actually. But then the lack of lighting information and materiality often makes it difficult to make decisions about the previsualization part. So the same process, rendering with Vantage again, and here, by the way, the rendering time is actually relatively slower because the previsualization typically is done on the larger scale projects. They dump all the data that can be there, whole cities and then if there is some basic particle simulation or dynamic simulation, some characters, they put everything there because you want to make a better judgment, and then this slows the rasterization engine. So in that case, we kind of again set the Vantage to render for the same amount of time, so say 3 to 4 seconds per frame, rendering it out, and then you see all this important information for lighting, shading, that allows you actually to get better result. We also added in version 2 ray traced fog,
Oh, right.
Which allows for God rays and light shafts and whatnot, which obviously is something that you cannot see from the viewport of the host.
Right.
Which changes the image tremendously. So,
awesome.
so all of these effects make it much easier for decision makers to actually work and detect issues earlier in the process and make important decisions early in the process, ultimately saving iterations.
Yeah, it's amazing. There's a lot of things. There's actually a lot more features, but there's one I want to touch on real quick because we're running out of time, and I know you have an 11 o'clock meeting.
No worries.
But we now support any hardware that does DXR. Is that correct?
Right.
That's a big one.
It's it's an enabler for sure.
Right.
AMD announced support for DXR a couple of years back.
Right.
And we actually wanted to support this one as well.
Right.
Their hardware as well.
Right.
So by the way, Intel also announced support for hardware ray tracing, and we're working on supporting that as well. But that's another topic. So with the release of Vantage 2, we added, we call it experimental AMD support because we haven't tested it thoroughly.
Right.
But
but theoretically, it will work, right?
It does work.
It does work.
We tested it on limited amount of cards, and that was the reason we branded it experimental, because we only tested on a handful of cards, and we couldn't test all the combinations of having two different cards in the same computer. So we don't know if this is going to be stable enough, but the performance is there, and a lot of the features of actually all the features of Vantage that are not vendor locked are available. And I'm calling those vendor locked because the NVIDIA AI denoiser works only on NVIDIA GPUs, so not available in AMD hardware. But we have the Intel Open Denoiser, which works on AMD GPUs. So if we remove those features, everything is supported on AMD GPUs as well.
Right.
And we're very excited to see users picking up.
Yeah, that's great. That's really cool. And
essentially, sometime after now the release, we'll be adding Intel support as well.
Right. But we have, I should, you and I, because we're kind of behind the scenes, we know there's some very exciting stuff coming up. So around what time do you think people should be keeping their ears open for some big announcements on some stuff?
Right. Well,
just give them a timeline. I'm not going to tell them what it is, but
timeline.
Tell them.
Right. Okay. Yes. Well, we're working on a lot of requested features.
Sure.
And we've been also dabbling our, interest in many different areas.
Sure.
So yeah, I can't promise anything, of course, but we expect something major around or maybe shortly after SIGGRAPH.
Okay.
Which was at August, so probably September for sure, to be on the safe side.
Yeah.
We'll have some major things if our R&D keeps going the way it is, and it's going well.
I will just say that my eyes went, oh my God, right? So some incredible stuff that's happening. So very excited about it. Well, listen, Simeon, I really appreciate you coming. We had a very nice deep dive into real-time and ray tracing, which is one of my favorite subjects. And congratulations on the success of Vantage. And
we drifted a little bit. Apologies for that.
No, but that's
Apologies
good.
for that.
No, it's good. I think it was really good that we did that, and I think people, hopefully at this point, will have a really good picture of what it's all about, and they can start taking advantage of it.
Hopefully, yes, great. Pun intended.
Good. All right, well, thanks, Simeon.
Thank you for reaching out, and it was a pleasure, as always.